It's finding the average. That's what the mean is. Sometimes you look and you see a study that says an average family has 2.3 kids. You go, 2.3 kids? What is a 0.3 kid? Just found out they're pregnant? No. We just take the number, we do a study, we calculate how many kids between them they all have, we divide by the number of families. So the mean is the average. And somebody said, well, you add them and divide by x. Well, we have two things. We have population mean, and we have sample mean. Now, for population mean, we use the symbol mu. When you see that, that means that's the population mean. For a sample mean, we use x bar. And the way you calculate the mean is you add all the values, the sum of all the values, and divide that by what? The number of values you have there. And if it is a population, we go as the sum of all the values divided by capital N, where capital N is the population size, small n is the sample size. So it's the same number, really. We just give it two different notation. But to calculate, that's the same thing. The sum of all the values divided by the number of values. Small n, again, capital N, that's your population size. And small n is the sample size. What's the advantage of knowing the mean? And what's the problem with the mean? There's some advantages and disadvantages with the mean. Let me give you an example. Let's say we ask people, we'll go back to that example, how many kids do you have? So this is the number of kids we ask people. How many kids do you have? The first one says, I have no kids, 0 kids. Next one, 3. Next one, 9. Next one, 4. Next one, 1. Next one, 2. Next one, 5. You're walking up and down Springfield asking people, how many kids do you have? You know we did not ask every single person. Right? So what's the mean here? That's a sample mean. It's going to be the sum of all these values divided by the number of values. Let's add them. Do we count the 0?
Yes.
Yes, we do.
We can count 9 twice.
Oh,
2.
I don't know.
Must be 2.
2 here? Where's my eraser? That's a 2. Can't read my handwriting. That's a 5. And 1, 2, 3, 4, 5, 6, 7 divided by 7. So 3 and 9, 12. 16, 17, 18, 19, 24. So 24 divided by 7. We can say the average family in Springfield has (24 divided by 7), 3.43 kids. Let's say we send another person I said, can you do the same study for us? So that's the first person did his study. We have two people doing it, two different sections in town here. Well, it depends on the nationality. Some nationalities, the more kids you have, the better. Middle Eastern people, Spanish people, usually they have a lot of kids. Italian too, 6, 7, 8 kids. So some cultures, they like to have a lot of kids. Asians, they don't have that many kids. So it depends, like if you have a section that's a lot of Middle Eastern or Spanish people, and you go, hey, number of kids do you have? Let's ask. They go, oh, why? We do want to study. Oh, we have 11 kids. I can tell you, I had a student in my class sat in the back seat where Kelly's sitting there. Matthew, his name, Matthew Frost, lives in Springfield. I said, Matthew, we're doing a class like this. How many brothers and sisters do you have? 18. He comes from a family of 18. So you put Matthew on that list, 18. Next one says 6. Next one says 5, 1, 9, 4. There's 7 people. So let's see what they mean for that sample. (11) plus 18 plus 6 plus 5 plus 1 plus 9 plus 4 divided by 7. Same sample size. 14, 19, 25, 35, 43, 43, 53, 54. So 54 divided by 7, and you have 7.71. We can say the average family in Springfield has 7.71 kids. So you can see it's very sensitive to the sample. Sometimes all you need is one person with really a high number to inflate everyone's numbers. So it's sensitive to data. That's advantage, disadvantage, depends how you look at it. And the other thing is you have to count every value. You can't skip any of them. So you can't ignore a value unless I'm not going to use it and pick somebody else. But you can't just ignore the values. Well, I got a 0. I'm not going to count the 0. I don't like the 0. I always tell people, do we count the 0? Goes, no. I go, well, think about it. If you don't count 0, what will happen if you take a test or you miss 5 exams, only take the last test, and you got 100 on it? Are we supposed to give you an A in the course? Well, if you're the student, you're going to say, of course, give me an A in the course. The truth is, you're not going to have an A in the course. You're going to have an F because you missed the first 4 exams. So we have to count every single value. Everyone is accounted for. There's no way to skip them. What about if your values are not single values like these? You did for homework assignment for us. I'll take actually the values you just gave me. Whereas the homework assignment, just hand back to me. We did that survey, how far you live from here. I'll take that Excel one, the nice and neat. Wait, there's 2 Excel now. Yep, there we go. So this is the homework, just hand to me. This is your sample. Hopefully it's correct there. We did a study. Now, we don't have the numbers. Notice the numbers are not here. So I'm given this frequency distribution table. I said, how far you live from the campus? That was the homework we gave you. And you guys had to measure the distance, come back and tell us. So we know as of now, let me just write that table down. 1, 2, 3, 4, 5, 6 classes. So we have from 3.2 to 5.8. You told me there's 6 people. That's your frequency. 5.9 to 8.5. We have 4 people. 8.6 to 1.2. We have what? 6 people. 11.3 to 13.9, we have 5 people. 14.0 to 16.6, we had 3 people. And 16.7 to 19.3, we got what? 2 people. That was the table you gave me back. At least one of you gave me that table back. Maybe yours is different. Notice we have no idea actually where you live. I don't have that data in front of me. So how am I going to find out what's the average here? What's the average distance for our students? How far from the campus they live? How do we calculate the mean there?
Midpoints.
The midpoint, good. So we'll do the midpoint. You want to find the midpoint for each one? X mid. What's the midpoint for 3.2 and 5.8? 3.2 plus 5.8, add them, and divide by 2, that's 4.5, right? Because when you add them, that's a 9. The next one is what? 5.9 plus 8.5, add them, that's 14.4 divided by 2, 7.2. So my class width happens to be 2.7. So if you add 2.7 to each one, if you add 2 to this, that'll be what? 9.9. Add 2.7 to this, 7 and 9 is what? 16. That's 12.16. Add 2.7 to this, 7 and 6, 13. 15.3. Add 2.7, that'll make it a 0. Is that 18? So we get the midpoint. So how do we figure what? Let me just close this one. How do we figure what the average is?
The frequencies multiplied by the midpoint.
So the sample mean here, when you have frequency distribution table, is the summation of f times x divided by what?
Total frequency.
The sum of f, which is the sample size. How many people took that survey? If you count how many people took that survey, you go 6 and 4, 10, 16, 21, and 5, 26 people. So let me multiply these two numbers, f times x, and add them. 6 times 4.5, 27. 4 times 7.2, 28.8. 6 times 9.9, is it 59.4? 5 times 12.6, 63. 3 times 15.3, 45.9, and 2 times 18, that's 36. Let's add them all. 27 plus 28.8 plus 59.4 plus 63 plus 45.9 plus 36 equals. If I add all the right buttons here, that's 260.1 divided by 26. It's 10 miles roughly, almost on the money. So we can see our average students live about 10 miles from STCC. 10 miles. Now, sometimes the experiment, you have a frequency distribution table, but you don't have classes. Like if we ask people, how many kids do you have? If we go downtown Springfield and ask, you're probably going to have a table that looks like this. It's not going to be a range of values, most likely it's going to say, okay, 0, 1, 2, 3, 4, 5, 6, maybe 7, top. So you have single values, and you have the frequency here. I get 10 people with no kids. I get 15 people with 1 child, 30 people with 2 kids, 45 with 3, 28 with 4, 17 with 5, and 4 with 6. So my table might have single values. You're still going to use that equation for it. You still have to use that equation to calculate what actually the average for that sample is. You go 0 times 10. This is x here, which is 0. 1 times 15, 15. 2 times 30, 60. 3 times 45, 135. 4 times 28, 102, 112?
56 times 2,
112. 5 times 17.
85.
Sure?
16 times 80, yeah.
Here. 6 times 4, 24. So the average for that will be, again, the same equation. So let me add them. 15 plus 60 plus 135 plus 112 plus 85 plus 24. 431 divided by, add all these values, and when you add the frequency, that's 149. And it's 2.89 or 2.9. You can see the bulk of the people just by looking at it. Look at the 30, 45, 28. The bulk of them are on 3. Your answer is somewhere in that neighborhood. Most of them. There's a few people toward the 1, there's a few people toward the 5. There's a couple of people toward the 10, the 0, a few people toward the 4. But the bulk of the people are right there. And that's what that number is telling you. That's what that mean is, the average. Now, another term that you hear here, median, and the mode. So let's look at the median.
That the same as a 50th quartile?
Quartile is 10%, 25%. We'll talk about the 4 quartiles. But give me a few minutes, I'll bring them in, the quartiles. Because you're talking about first quartile, second quartile, third quartile. Before I leave the means, sometimes I actually have weighted means. Before I forget about that. And that's a little bit different. When we give a test, like look at the grading we have for this course. We're saying what? The homework, for example, some of my class, the homework counts for what? 30% of the grade, not in this class. The quizzes count for how much? 20%. Most of my class, that's how I do them. And the exams count for what? 50%. So each one has a different weight. So if my average for the homework average, let's say it was an 85. And my quiz average was a 90. And my exam average, let me lower it intentionally, it was a 70. To find your average in the course, you don't just grab these numbers, add them, and divide by 3. Doesn't work that way. Because each one has a different weight. So to find the average for the students in the class is going to be what? The summation of each x value times the weight. divided by what? The sum of the weights. So in this example, this will be 85. The weight of that is 30% times 0.3. Add to it 90 times 0.2. Add to it 70 times 0.5. And you divide that by the sum of the weight. What's 0.3 plus 0.2 plus 0.5? 1. $85 times 0.3 plus 90 times 0.2. 0.2 plus 70 times 0.5. The average is 78.5. Where if you just took the values and add them and divide by 3, if you just added these numbers, 85 plus 90 plus 70, if you just added them and divided by 3, you have an 81.7, which is B minus. But now your average or your grade is what? C plus. Because the exams weigh a lot more here, and you don't do as well in the exams as the other stuff. Another example for weighted values, I'll give you another example that you probably use all the time, your GPA on campus here for the semester. Let's say you're taking 4 classes this semester. You're taking EGR 211. That's a 3-credit course. You taking Calc, Math. Calc which one? 3. Calc 331, I think. Is it 331?
330.
I think it's 233.
233. That's a 4 credits. Anyone's taking physics? Physics 231. That's 4 credits. And let's say you're taking English Comp 2. English Comp 2 is what? English 102. That's 3 credits.
Then yoga for 1 credit.
Yoga. I don't know what the code for yoga.
Yeah, for 1 credit.
1 credit. That's for people who want to be full-time.
YNG,
Huh?
YGH.
YGA is it? That's what that is?
Wait, we actually offer a yoga class?
We do, yeah.
Oh,
It's a 1 credit course. It is actually. For people who just want to be full-time, you can take yoga, or you can take Google, like learn how to use Google, or research. Now, let's say you got a B in this class. A B is worth how many points in your GPA?
So 3.0.
3.0. That's for the EGR. For Calc 3, you got a B plus. 3.3. That's what a B plus. So this is a B. This is a B plus. Forget about physics. That's a C. Oh, I'll give you a C there. That's a 2. Be realistic there. English, you got an A minus. 3.7. And yoga, you got an A in it. You're flexible. That's a 4.0. Notice each one has a different weight, because the credits are really your weights. That's your W, the weight, and that's the value. So what's your GPA? It's 3 times the weight, which is 3 points, or 3 credits, plus the 3.3 times how many? 4, plus the 2 times 4, plus the 3.7 times 3, plus the 4 times 1. Divide that by, that's your weight here, the sum of W. How many credits are you taking? 3 and 3, 6, 10, 15. And now we got your GPA for this semester. So it's 45.3 if I push all the buttons again, over 15, which will make it what? 3.02. Now just think, if you drop that physics class, you know what, I'm not doing good in physics, I'm going to drop it. If you drop it, that doesn't count toward your GPA. If you just did the other class, I'm curious about the average, 3 times 3 plus 3.3 times 4
45.3 minus 8.
plus, you could, 3.7 times 3, I already did that, plus the 4. And now you're going to divide, instead of 15, you're going to divide by what?
11.
By 11. Your GPA 3.4.
So you're saying we should drop physics?
Yeah.
Well, if you're on the bubble there, especially if you're on C minus, you know, like, I'm not taking that chance. Or talk to the teacher first. But that's a weighted average, weighted mean. I just don't want to leave that subject untouched there, because you might see that while you're doing the homework, or you hear about weighted mean. Now, the next topic here, in the same section, I hate how I can't move up and down. Okay. Let's talk about the mode and median. Median. And I'm not sure if it's the same section, probably not with the notes. So when you watch my notes there, class notes, PowerPoint, median is the middle value. That's what median is. When you have numbers and we say, what's the median? So let's say we give you these values, 50, 70, 90, 40, 80. What is the median?
96.
I think it's 90 because the middle, but I didn't mention one thing. I didn't forget, I just said, left it out intentionally. Before you answer that question, which value in the middle, what do you need to do first?
Lowest to highest.
Sort them. Put them in order. If you put the numbers in order from small to large or large to small, it doesn't really matter. You end up with what? 40, 50, 70, 80, 90, and that's your median. That's the middle value. Why? 50% of the values to the left of it, 50% to the right of it. 50. You asked me about quartiles. This is actually Q2, second quartile. Yep, because Q2, think of 2 quarters. It takes the list, it separates the 50% below, 50% above the number. The problem with these, what happens when you have an even number of values instead of odd? Odd, it's the middle one, it's easy. What about if you have numbers like this? I'll put them in order even. 40, 45, 50, 60, 70, 80. Yes, you can't use the 50 and you can't use the 60. 50 has 2 values to the left, 3 to the right. That's not it. You go, oh, maybe it's not the 50, maybe the 60. 60 has, 3 to the left, 2 to the right. That's not good. So what do? You take the 50, add to it the 60, the two middle ones, add them and divide by 2, which is 55. And that's your median. That's the median. How many values less than 55? 3. How many values more than 55? 3. It cuts the list into 50-50. Question? What about the mode?
So that's X tilde, right?
Yes.
Is that only for samples, or is that for population? Would you have to tilde
It's almost impossible to get a population, really, unless, again, we're looking at the Supreme Court justice, a small number. In real life, almost everything you're going to be dealing with is sample. It's so difficult to get everyone to respond to any survey that you do.
Does it matter if, say, you had continuous data acquisition versus discrete?
Oh, don't worry, continuous is coming later. Yeah. We can tell that, but that's coming up later. Once we finish with this, we'll come back and recalculate all this when you have continuous function. So as we said last time, we're going to tackle this as your first statistics class, which is to you, most of you, that's probably the case. So we're going to go over the stuff quickly, then come back and start doing the continuous one. The mode. Mode is what? Most frequent, right? Which number showed up more often than the rest of them? So if I give you these values, I say, oh, these are the first result on quiz 1. Quiz 1, we're out of 10. We got a 5. Somebody got a 6, a 9, a 7, a 1, and an 8. What is the mode? No mode. There's not a single number that showed up more often than the rest of them. On the other hand, if I go, well, we got a 5, 6, 9, 7, 5, 8. My mode is what? 5. If I have 5, 6, 9, 7, 5, 6, what's my mode?
We have 2.
Two modes. 5, 6. Both are modes. So for modes, you don't add them and divide by 2 like we did with the median. You just list them. Or if you have 5, 6, 9, 7, 5, 6, 5. What's the mode? Back to 5. 6 is no longer a mode because the 5 showed up how many times? 3 times. So that's what the word mode is, most frequent. You also hear the range. The range, it's usually the high value, the maximum value minus the minimum.
Quick question.
Yes.
Do you have 2 modes, say you have the same counts for 2?
Yep. You can have 2 modes. We did that here. It's called bimodal. You have 2 modes. 5 is a mode, 6 is a mode.
Isn't mode kind of one of the least useful statistical things? Because it doesn't really tell you all that much except that it happened more than once.
True. They're probably the most useful ones, and especially for a teacher, for us when I'm teaching. Anytime I give the average at the end of the test, I'll give the average and I will give also the median. Because if I said the class average is 85, and you go, oh God, I'm in trouble, I didn't do well. I got an 80 on this test. I'm not doing good in the class. But if I came back and I says the median for the class, median was 74, then you're not doing so bad in the course. Why? You're in the top half the class. Why is the average high? Because there's colored people got 100 on it. It raised everyone's average. But you're probably the third, fourth highest value there. You know. So I tend to give both of these numbers because one without the other you can't really tell. If you just gave you the median, you go, well, the median might tell, oh, I'm in the top half, the bottom half, that's it. You know. But if you give both, if you said the median was 74 and you got an 80, you go, okay, I'm good. But if I come back again, I said to you, and the mean was 90. If you have a class of 20 people, that means you're in the top 10. But because this number is high, you're probably number 9 or 10 on that list if you have an 80 or 85. Because the average, notice the average was a 90. That means there's a lot of high scores. A lot of people got higher than you. Or if I come back and I say, guess what? The median was 74 and the mean was, I don't know, let's say 81, 82. And you got an 80, you're probably third or fourth highest one in the class. So one by itself doesn't give you the full story. So when you see both of them, you can predict, you can anticipate where you are in the class by looking at the average and the median. You can say, oh, I'm doing really good, I'm not doing so good. You know. The range is the difference between the highest value and the lowest value. So we'll use TOPI your exam. You had physics 1 test result, you got your test back, here we go. 20, 25, 32, 64, 48, 71, somebody got 71, woo-hoo. 41, 53,
96.
You got one Adrian in the class.
And 96.
96, okay. So what is the range here? The range is going to be a really big value because it's the highest value minus the lowest value, which is 76. That's not good. That says the score is spread really all over the spectrum, you know? So if you were like, if you want to do a scatter graph and just plot these dots and see what every student is, like you have the graph looking like this, you go, this is the 10, this is the 20, the 30, the 40, the 50, 60, 70, I'm having a hard time writing the 70s, 60s, 80, 90, and 100. You'll notice values like this, all the way spread, all over. Where on the other hand, if we said same, not the same class, we'll take calc. You know Burns is easy. So again, we're looking for the range. The range is the high value minus the low value. So you took Mr. Burns' test in Calc 3 and you got 80, 84, 86, 92, 81, 75. So when you look at that, what's your range? It's 92 minus what? The 75 was it 17? So the gap between the lowest and the highest value is only 17. That means here's what happened to the scores if you look at them. The other one was spread all over. If we do the same scale, if we go 10, 20, 30, 40, $75 is somewhere here. 92 is somewhere. The score is like this. They're all like in this section. So everyone did fine. Everyone passed the course. Compare it to physics. Where's physics? Where'd you go, physics? Look where the scores are. All over. This one, all of them right here. Concentrate on each other. The average for that should be somewhere here on the 80 for that one too. But the range will give you the high value minus the low value. Again, if we're designing, like, look at this here, this eraser. Notice that little piece turns here. So when you design these, you want the range of the thickness of the diameter here to be really small. Because you want the gap between the smallest one and the biggest one, you want them all to be the same size. Ideally, that's what you're hoping for. You're not going to get them all the same size. Might be off by 1/10 of a millimeter. So they're all going to be around that length there. If they are spread over like we saw in physics, that means some of them is going to be this big from here to there. It's not going to fit there. And some going to be tiny one. It's not going to fit there because they're spread all over. The next piece actually, oh shoot, is calculating the standard deviation, but I'm looking at the clock and I have to wait on that, so I'll do that next class, calculate the standard deviation. Then after we finish with that, we'll have a homework on it and test number 1 probably coming up soon. If I have to guess on test number 1, I will say not next week, but the week after. You know. So probably on Tuesday I'll finish this chapter,